Let us start our video number 3, which includes question number 7, 8 and 9 on the topic waves. Here we'll be taking up IGCSE past paper questions. These are the real IGCSE past paper questions, and previously also we have done video 1 and 2. We have taken up more questions. They were numbered question number 1 to 6. So let us start with the question number 7. A wave passes along the surface of the water in a rippled tank. Describe the motion of the molecule on the surface as the wave passes. So the waves in the water as it passes through the water, what kind of the water wave? What kind of the wave are the water waves are? They are transverse wave. Water waves are transverse wave. So if you are taking up any particular molecule, how is this particular molecule moving? It is moving up and down. Alright, so let us read the question again and understand what they are talking about. A wave passes along the surface of the water in a ripple tank. So we have drawn the wave here. Describe the motion of a molecule on the surface as the water passes. We have taken up a molecule. How is it moving? It is moving up and down. It's a 1 mark question. They do not require any explanation. Just describe. You say it moves up and down. Let us look at the mark scheme as well. Molecule moves up and down, or you can say it rises and falls down. Or other variants of the answer could be, if you are very technical about talking about transverse wave, please do go ahead and write it this way. It oscillates perpendicular to the direction of the wave. Or you can also describe your answers in circle. Any one of these ways of writing the answer will get you 1 mark. Alright, so simple terms, let us write it down. It moves up and down, which is perpendicular to the direction of the wave travel. How is the wave traveling? Wave is traveling left to right, and both these are, if you see, 90 degrees. The angle between them is 90 degrees. Let us come to the part B. In the figure 7.1, this is the picture they are talking about, shows a view from above the water wave approaching a narrow gap in a barrier. So you have water waves, it is approaching a narrow gap in the barrier. The water on both sides of the barrier have the same depth. Same depth means you negate that refraction would be taking place. There is only a gap, so diffraction would take place. On this figure, sketch the pattern of the waves in the region to the right of the barrier. 2 mark questions, that means the examiner is looking for 2 valid things. Show some diffraction and make sure that the wavelength in your answer stays the same. Diffraction. Alright, wavelength is staying the same. How do you depict it? Spacing between the consecutive wavefronts. This spacing should stay precisely the same. Alright, 2 mark question. Let us look at the mark scheme as well to tally. Why 2 marks? 3 arcs, at least 3 arcs. Angular spread greater than 90 degrees. Okay. And okay, same spacing. 1 mark, at least 3 circular arcs. 1 mark. 2 marks. 1 plus 1. Alright, let us come to the next question. State the process by which the wave arrived at point P. This is a point P given to you in the question, to the right of the barrier. So, question straight away tells you what is the name of the process which is happening here. It is diffraction. 1 mark question, you have to just give the name, no explanation required. Next question, the wave approaching The barrier has a wavelength given to you, 1.4 centimeters, and a speed given to you. Calculate the frequency. Now these kind of questions we know we are doing again and again. There is one formula in the chapter wave, V is equal to F lambda. So frequency is V over lambda. You're given both V, which is the speed, and the wavelength. Divide these two numbers and you should get your answer. Let us look at the mark scheme. Yes, look at the mark scheme. They are also writing the formula. Always a good approach that you write the formula. V is equal to F lambda. Substitute the values and find the value of F, which is 12 over 1.4, which is 8.57 Hertz. Correct to at least two significant figures, 8.57. Your answer should be ultimately 8.57 Hertz. Right? Now the wave equation, V is equal to F lambda. Even if you forget this equation in the examination hall, sometimes students get to confuse. They think if V is equal to F lambda, or F is equal to V lambda, or lambda is equal to FV, what is the correct equation? They get confused. Whenever you are confused, because you have a lot of syllabus to prepare for, it is but natural that you might get confused on tiny small things here and there at times. It's okay. Use the unit to verify which is the correct formula. Use the unit on the left hand side and the right hand side to compare. So what is the unit for speed? Meters per second. On the left you have the unit meters per second. What is the unit for frequency? It is Hertz. But the other formula for frequency is 1 over time. Frequency is 1 over time period. So unit for frequency is 1 over seconds. That's the other unit for frequency, which is same as Hertz. Both mean the same thing. 1 over seconds or Hertz, both mean the same thing. So let us not write Hertz, because Hertz comes from the name of the scientist. Let us write the simplest form of the unit, which is 1 over seconds. The wavelength is measured in meters. Are the units on the left hand side and right hand side same? Yes, they are same. So this is the correct equation for V is equal to F lambda, which is the wave equation. And the other units, if you write down their units on both the sides, you'll see that the left hand side will not be equal to the right hand side. The units will not be equal. So this was a simple strategy to sometimes verify if you're understanding your formula that you remember is correct or wrong. It's very natural to forget the formula at times. Use this strategy in the examination anytime, be it any formula. Question number 8. A long rope fixed at one end is being used by the student to demonstrate transverse wave. State what the student does to the rope to produce the transverse wave. Easy question. You have to move it side to side or up and down. Let us look at the mark scheme. Shake the end of the rope. Example, from side to side or up or down. Basic questions on transverse wave. Let us move on. On the figure shows a sketch of the rope where transverse wave is present. So you see some transverse wave present here. On this figure show a distance labeled lambda corresponding to the wavelength of the wave. Right? You have to label the wavelength. So peak to peak, peak to peak. Make sure that your line is moving all the way from one peak to the other peak. That's your lambda. Do not mark a line something like this. No, it's wrong. Make sure that your arrow is starting from one peak and moving to the other peak, or else you can also draw the wavelength as a trough to the next trough. Trough to trough. Both of them are lambda. You can draw any one of them, but for teaching's sake I am showing you both the things. Now the second part says a distance labeled alpha A corresponding to the amplitude. How do you draw the amplitude? First you have to draw the center line. Let us draw the center line of the wave. It would be something like this. Center line of the wave. Before drawing the amplitude, this is from the basics of wave, the first video on the chapter wave, where we spoke about the basics, how to find the lambda, how to find the amplitude. Go through it if you do not know how to find the amplitude. Amplitude is the distance from the peak to the center line. This is your amplitude, or from the trough to the center line. You can draw any one of them. Both are not required. You can draw any one of them, because they are saying a distance, one distance only, right? But for teaching sake, I am drawing two. Now the third part of the question. Suggest what the student could do to reduce the wavelength of the wave. Reduce the wavelength. How can he reduce the wavelength? Let me erase this. He can produce on the same wave more number of waves. More number of waves present on the same rope. More number of waves present on the same rope will reduce the wavelength. If you see the red lines, you have more number of waves now present. The wavelength has gone down as compared to the previous wavelength. This was the previous wavelength. The wavelength has gone down. So how do you get the more number of waves? Increase the frequency, or increase the movement of your hands. So what do you say? Increase the frequency of the movement of the hand while producing the wave. While producing the wave. Let us see. Increase the rate of shaking end of the rope. Shake faster or move more quickly. Alright, easy question. The diagram here represents a wave on the surface of the water in a ripple tank. Looks like the next question is on refraction. The waves are traveling from the deep water across a boundary into a shallow water. So you have deep water on one side and shallow water on the other side. Explain how the diagram shows that the wave travels more slowly in the shallow water than in the deeper water. Okay, so you have to explain why the wave is more slow, why the speed has gone down in the shallow water whereas the speed was high in the deeper water. So how do you explain this? Look at the wavelength. Where is the wavelength high? The wavefronts are far away here. The wavelength is high in the deep water. How about the spacing between the wavefront in the shallow region? Gone down. The wavelength as well has gone down. This is something that you have to prove. The things that I am putting in the box is what you have to prove. And the wavelength is something that you can visually see with your eyes. What do you visually see? That the wavelength is going down. So how do you say that? You say that the wave equation says V is equal to F lambda. Frequency stays constant. If you are not sure about this part of the theory, please go through my video on refraction and reflection. The frequency does not change. And what do you see? You see that I see that lambda has decreased. Decreased where? in shallow water. So what happens? If the lambda is going down, the speed has to go down so that the wave equation holds true. So in the last statement you'll write, if lambda goes down, you'll write the full statement. If lambda goes down, so we will have to go down so that wave equation holds true. Right? The left hand side should be equal to the right hand side. Frequency stays constant. I see that lambda has decreased. You see it clearly that the wavelength is going down in the shallow water. So if lambda goes down, so v has to go down, so speed has to go down so that the wave equation holds true. Let us look at the answer. In shallow water, wavelength is smaller, the lines are closer together, frequency is constant. 1 point for this statement, 1 point for this statement, and 1 point for writing the wave equation. 3 points, 3 marks, and you scored 4 marks, 3 out of 3 on this question. 1 mark for stating frequency is constant, 1 mark for writing the wave equation, and 1 mark for inferring that the wavelength is going down. Visually you can see that. Alright, so let us come to the next question. Shows a view from above of the water on the surface of the water in a water tank. So you are given a water tank, wavefronts are coming in. The wavefront AB, they are talking about wavefront AB, so let us look at the wavefront AB. It's traveling in the region P. It is traveling in the region P towards the region Q, where the water is shallower. Okay, region Q, the water is shallow. The water is shallow here. The water is deep here. Right? Sometime later, the wavefront has moved to region Q. So the wavefront AB, which is in the region P, after some time it reaches the region Q. State, okay, so here CD, CE, CD, CE and CF are suggested position of the new wavefront. State which is the correct position of the new wavefront. So state which is the correct position. So clearly you know that the wavefront has to bend towards the barrier. Only CD is showing bending towards the barrier. So the correct answer should be CD. CE, if you look at, or CF, doesn't make sense. They're bending away from the barrier. Doesn't make sense. CD is the correct answer. Explain your answer to 1. Explain your answer here, 4 mark question. Same kind of a reasoning you'll have to give, which we just gave here and which we have been giving every now and then on the questions on refraction. Question number 8, the similar kind of a reasoning goes here as well. Let's come to the next part of question number 9. The figure shows the wave after a change is made to the way the tank is set up. The experiment is repeated. Now in the B part, they are making some changes in the tank and the wavefront are moving as it is shown here. The wavefronts from the position AB in the region P now moves to the region CG, to the position CG in the region Q. State the change that has been made and explain your reasoning. What change do you think has been made? AB has moved to CG. Do you see any change in the wavefronts? They are moving straight parallel. Straight parallel. No change, no bending occurring, no bending, no turning, nothing happening. So what change do you think has been made from picture 1 to picture 2? In picture 1 there was bending happening, there was a deep and a shallow region. In picture 2 See that the wavefront is moving as it is. So what they have done in picture 2, think about it. Yes, if you say that the change is that the depth of region P and Q has been made same or equal. The depth of P and Q are now equal. Explanation, 2 mark question, 1 mark for writing your answer correctly for change. Explanation, why? Because you do not see any bending happening. You do not see any refraction happening. Any of the things you can say to get the next 1 mark here. So let us go to the mark scheme and see. Regions P and Q have same depth. Region P and Q, 1 medium. That gives you 1 mark. What gives you the other mark? You see no refraction happening, no change of direction, no bending of wave. It gives you the next mark. Easy and simple question, not so difficult to understand. So we have solved 9 questions, past paper questions of IGCSE on the topic waves. Hope it helps you to understand the topic, to understand the theory. Please, I would request that go through the theory wherever I have mentioned where the question relates to any particular theory topic and you do not understand, go back to the theory videos, watch them. This will clarify all your doubts about waves and will prepare you to score 100% marks in this topic. Thank you.